Reduction and oxidation in aldehydes and ketones. First, reduction to alcohols. Reduction to alcohols. Aldehydes and ketones gets converted into the corresponding alcohols on reaction with nickel or palladium catalyst, okay, or in the presence of sodium borohydride NaBH4, sodium borohydride, or lithium aluminum hydride, okay, or nickel or palladium catalyst, okay. So aldehydes and ketones gets reduced and form. Aldehydes form primary alcohols and ketones form secondary alcohols. Let us see the reaction. CH3 CHO. First aldehyde. CH3CHO on hydrogen, on reaction with hydrogen, nickel or palladium catalyst gets converted into CH3 CH2OH. CO group is reduced to CH2OH. Okay. Next, in the case of ketones, C double bond O CH3 plus H2, presence of nickel or palladium catalyst, CH3 COH CH3. Okay. This is a secondary alcohol, that is 2-propanol will be obtained. Okay. So aldehyde gives primary alcohol and ketones give secondary alcohol. Next reaction is reduction to hydrocarbons. Aldehydes and ketones gets converted into corresponding hydrocarbons. There are two types of reactions. There are two methods. First method is Clemmensen reduction. To hydrocarbons. Reduction to hydrocarbons. Okay. First Clemmensen reduction. First reaction, Clemmensen reduction. Okay. In this reaction, aldehydes and ketones in the presence of zinc amalgam and concentrated HCl, on reaction with zinc amalgam and concentrated HCl, the CO group gets reduced to CH3 groups. Okay. CO groups reduced to CH2 groups. Okay. So first reaction, Clemmensen reduction. Let us see the reaction. CH3 CHO on reduction. Okay. In presence of zinc amalgam and concentrated HCl, reaction takes place, gets converted into CH3 plus H2. Okay. Reduced. CO group is reduced to CHO group. Next, let us take one ketone, CH3CO C6H5 plus 4H. Similar reaction takes place. Zinc amalgam and concentrated HCl. Okay. CH3 CH2 C6H5. Okay. Plus H2. This reaction takes place. Okay. This is the first method. Next, second method is Wolff-Kishner reduction. Second method, Wolff-Kishner reduction. Okay. This reduction takes place in the presence of hydrazine. Okay. On heating aldehydes and ketones with hydrazine in the presence of KOH, potassium hydroxide, in highly boiling solvent like ethylene glycol, reaction takes place and corresponding hydrocarbons are obtained. Let us see the reaction. CH3 CHO. Okay. On reaction with hydrazine, NH2NH2 is hydrazine. Okay, hydrazine. In presence of KOH, okay, KOH with highly boiling solvent like ethylene glycol. Okay, ethylene glycol. Reaction takes place. CH3 plus N2 plus H2. Reaction takes place like this. Okay, so aldehyde is reduced to the corresponding hydrocarbon. Okay, these are the two methods for the reduction to hydrocarbons. Next, oxidation reactions in aldehydes and ketones. Oxidation. Okay, here aldehydes can easily get oxidized to their corresponding acids on treatment with common oxidizing agents like HNO3, acidified KMNO4, then K2Cr2O7, dichromate, etc. Also, it gives mild, it oxidized in the presence of mild oxidizing agents like Tollen's reagent, then Fehling solution, etc. We will discuss this. Fehling solution, etc. Okay. These are mild reducing agent. But in the case of ketones will not give these oxidation reactions with these mild oxidizing agents, or ketones gets oxidized only under vigorous conditions. Let us see first in the case of aldehydes. Aldehydes on oxidation with common oxidizing agents like K2Cr2O7, acidified K2Cr2O7. This gets oxidized to CH3COOH. Okay. Acetic acid will be obtained. But in the case of ketones, common oxidizing agent will not work. So, we are using strong oxidizing agents like alkaline KMNO4, or concentrated HNO3 we have to use for the oxidation of ketones. Also, while oxidation, what will happen is ketone will oxidizes to the corresponding acids which are having carbon atoms less than the parent ketone. Okay, and let us see the reaction. CH3CO, CH2CH3. Ketone on oxidation, it gets converted into, here the breaking takes place. It gets converted into CH3COOH plus CH3COOH. Here in this case, we can see that the CO will move along with the smaller alkyl group. This rule is known as Popov's rule. Okay, this rule is known as, that is, the CO group will preferentially with smaller alkyl group. So the breakage will take place here. This rule is called as Popov's rule. Okay, so we will get two different acids which are having carbon atoms less than the parent ketone. So this will be the reaction takes place in the case of ketones, and ketones will not oxidized with Tollen's reagent and Fehling's solution. So this is an important test to distinguish. So Tollen's reagent and Fehling solution test is an important test to distinguish between ketones and aldehydes. Okay, ketones and aldehydes. Okay. See the oxidation reaction of aldehydes with Tollen's reagent and Fehling solution. First, Tollen's reagent. Tollen's reagent is ammoniacal silver nitrate solution. How can we prepare this? Ammoniacal silver nitrate solution. Okay. So, Tollen's reagents can be prepared by adding ammonium hydroxide to silver nitrate, AgNO3. Okay. First, a precipitate of Ag2O will be obtained. Okay. After some time it will dissolve and form a clear solution. Okay. Like this we can prepare Tollen's reagent. Okay. Tollen's reagent on reaction with aldehydes, what will happen? It will get converted into their acids. Okay. Tollen's reagent with aldehydes. Ketones will not give this reaction. Tollen's reagent on oxidizes aldehydes and form corresponding acids. Okay. And also at the same time, the silver ions present in the compound, in this solution, is reduced to, silver ions is reduced to metallic silver. Okay. It gets reduced to metallic silver. Then what will happen? This metallic silver get deposited on the walls of the test tube and gives a silver mirror. This test is called as silver mirror test. Okay. So we will get a silver mirror test in the case of aldehydes on oxidation with Tollen's reagent. Now let us see the reaction. First RCHO, aldehyde on reaction with, in the solution, the ions will be like this. Okay, 3OH minus. So, this aldehyde gets converted into carboxylate ion. Okay, plus silver metal is obtained plus 2H2O plus 4NH2. This will be the reaction in the case of Tollen's reagent. So, silver metal is obtained and it gives a silver mirror test. Okay. This is the reaction with Tollen's reagent. Next, Fehling solution. Fehling solution is a mixture of two solutions. Fehling solution A and Fehling solution B. Okay. Fehling solution. It's a mixture of two solutions. Fehling solution A. Fehling solution A is, this is A. Fehling solution A is aqueous copper sulfate. This is aqueous copper sulfate. Okay. And Fehling solution B. Fehling solution B is alkaline sodium potassium tartrate. Alkaline sodium potassium tartrate. Okay. This is also called as Rochelle salt. Rochelle salt. Okay. So these are the two solutions. Okay. First, so Fehling solution A is aqueous copper sulfate. Fehling solution B is alkaline sodium potassium tartrate. First, we have to take the equal amounts of these two solutions. This solution is called as the Fehling solution. Okay. First, equal amount of Fehling solution A and Fehling solution B are taken before the test. Okay. On heating aldehydes with this Fehling solution, what will happen? A red-brown precipitate of Cu2O, copper oxide, will be obtained. We can see the reaction. Okay. So, what we add, aldehydes are oxidized to carboxylate ion. So, we will get a red-brown precipitate if Fehling solution is added to the aldehyde. So, this is an important distinguish test between aldehydes and ketones. Ketones will not give this reaction. And the reaction is as follows. RCHO plus Cu2 plus 5OH minus gives, aldehyde gets converted into carboxylate ion and a red-brown precipitate will be obtained. This is red-brown precipitate. Okay. Red-brown precipitate. Okay. This is the test. So, this is a weak oxidizing agent. Weak oxidizing agent. Only aldehydes give this reaction. And aromatic aldehydes and ketones will not oxidize this mild oxidizing agent. Okay. Aromatic aldehydes and ketones will not give this reaction. Okay. So this is an important test for the distinguish between aldehydes and ketones. Okay. Next, haloform test or haloform reaction. Okay. Okay. This reaction gives only for methyl ketones. Methyl ketones, that is one CH3 attached to C double bond O group. Such ketones only give this reaction. Okay. So one methyl group linked to the carbonyl group are oxidized in the presence of sodium hypohalite. Sodium hypohalite. That is NaOX. So in the presence of this, what will happen? The CH3 attached to the CO group, carbonyl group of ketone gets oxidized, or the compound is oxidized, and this CH3 groups gets converted into a haloform. We will discuss the reaction. Okay. So the methyl group gets converted into CHX3. Okay. CH3 groups attached to CO group gets converted into CHX3. Okay. This, and if there is a C double bond group, C double bond C group in the other side, that will not affect the reaction. Let us see the reaction. Okay. First, ketone RCO CH3. CH3 attached to the carbonyl group. Such compounds only give this haloform reaction. That on reaction with NaOX, what will happen? C double bond OH. So this group gets oxidized and converted into the corresponding sodium salt. Sodium salt of acid. Okay. Then next part will gets converted into CHX3. Okay, this will be the reaction. Let us see one reaction which contains a C double bond C group. Okay, H, CH3, then C double bond O, CH3. So this part will not affect the reaction. Okay, one CH3. Now reaction with NaOX, what will happen? C double bond C, H, CH3, CH3, okay. Then CONA, C double bond plus CHX3. This will be the reaction. Okay. So similarly, the iodoform will, if we are using sodium hypoiodide, we will get iodoform. So iodoform reaction is an important reaction to detect the presence of CH3CO group. Okay. Let us see the reaction, the iodoform reaction. How the iodoform reaction takes place. Iodoform reaction. NaOI3. Iodoform reaction. Okay. So first ketone on reaction with iodine, 3I2 gets converted into CI3COCH3 plus 3HI. Okay, this get converted into corresponding iodoform. Okay, CI3COCH3 plus NaOH. So in the presence of NaOH and iodine, the reaction takes place and this gets converted into iodoform, CHI3 plus CH3COOH. This reaction takes place. This reaction is called as iodoform reaction. So by this reaction we can detect the presence of COCH3 group in the ketones. Okay. Okay. Sodium salt will be obtained.